Here I've drawn an isosceles triangle, and these are the congruent sides. This is the vertex angle, so that makes it this the base, and that makes these two angles the base angles. Our goal is to prove that these two angles are congruent. Now the hint that I gave you was to draw a line, and so the line we want to draw is this one. And what we want to do, let me call this A, B, C. And so with this new point here, I'll call it D. What we want to do is prove that angle B is congruent to angle C. And the technique that we're going to use is drawing in this altitude. We saw earlier that this altitude on an isosceles triangle connecting the vertex to the base has got several properties. First, being an altitude, it's perpendicular to the base. That's important. We also know that it's the bisector of the vertex angle, so we know that those two angles are congruent. And we also know that this bisector bisects the base. So we know that this line segment from B to D is congruent to this line segment from D to C. I want you to think about the triangles that we created with this line being added. Let's extract them. We have this. This is B, A, and D. And we have this. And this is A, C, and D. And we already know that AB is congruent to AC. We know that BD is congruent to DC. And because AD is a line segment that is symmetric, or I'm sorry, transitive, I said it wrong again. It's reflexive. It is congruent to itself. When we extract the triangles, we get AD and DA, and we know that it's symmetric so that this side is congruent to that side. So when we look at the way that we've created these two right triangles, we see if we make A and B correspond to AC, AB corresponds to AC, and they're congruent. So AB corresponds to AC, and AB is congruent to AC. And so we do that for all of our corresponding sides. We say BD corresponds to DC, and BD is congruent to DC. And then we have AD corresponds to DA, and remember we're calling it backwards just to make an emphasis that they are two different line segments when we pull them apart. And AD is congruent to DA. Forget the cat, or forgive the cat. She's going to have fun with us here. So look what we have here. We have side, side, side. So that tells us that triangle ABD is congruent to triangle ADC. And so what we do is we look for the corresponding angles, and that's B. Hi, cat. Keep going. Keep going. There we go. So we have angle B corresponds to angle C. And because of SSS and the fact that the two triangles are congruent, that gives us, let's put it as a therefore. And I don't know if I've explained this before or not, but the 3 dots in a little triangle like that is a shorthand way of writing therefore. So we say therefore angle B is congruent to angle C. And so we have proved what we set out to prove. These are our base angles, B and C. We have proved it using SSS that B is congruent to C. So the base angles are congruent. Now, we could have proved it another way. We still do the same, draw the line and split the angles. But if you remember earlier, we had a property that said that if we've got the legs of the corresponding legs of two right triangles are congruent, then the two triangles are congruent because they're right triangles. And in case you hadn't already figured this out, this is true because of side angle side. We have a side, and the included angle is the right angle, and we have the side and the side and the corresponding, I'm sorry, let's say it again, the included angle is the right angle. And so by SAS, or by that property that we talked about earlier, that the right triangles are congruent, and therefore their corresponding parts are congruent. So there you have it.